Okay, so let's kind of see where we're at on our process here. We've done 1, 2, and 3, and we just got done determining the forces generated by our machine elements. So we did the gears, we did sprocket, and then we also did a sheave. Okay. Now what we're ready to do is we're ready to determine the direction of those forces on our shafts. Okay. So we are going to generate, I'm going to turn the page on page 528 here. We're going to be generating the free body diagrams of the front view and the top view of our shafts. Okay. And the reason we need to do that is because, as we know, there are forces in two orientations 90 degrees to one another. There's going to be forces that are going to be kind of like, if you would, in an X plane and a Y. All right. So we want to be able to see those in both orientations, draw the free body diagrams, and use these to then input into MD solids to get our shear and moment diagrams. Okay. So we're going to create these, but we're going to use MD solids to aid us in that. But before we can use MD solids, we've got to know the directions of our forces first. Okay. We've got to know the directions of our forces. So what we're going to do is we are going to draw that front, right, and top view of our orientations. And I'm going to go back one level here. Okay. And what I'm going to have you do is I am going to have you create the front, top, and the right side view. So I'm going to go underneath here first, I guess. I'll go back and forth. So I'm going to start with front view. Top view. And this is just basically the center line. I'm not technically drawing the shaft really. And then I'm going to do a right side view over here. Oh, I have it. I got my circle template. You don't have to do a circle template, but make as nice of circles as you can. Okay. And now what we're going to do is we're going to start on the left-hand side here. It's going to be my point A. Kind of looking 6, 6. It looks like we're 6 inches between each point. So I'm going to go over here. This is going to be my E. I'm going to try to make this as even as possible. And then in about the center, it's going to be my C. And then they'll be between these B and D. Yeah. So labeling is going to be A, B, C, D, and E. Okay. Now looking down this axis, this is going to be the x-axis on my front view. And it's going to be my y-axis going vertical. And then my Z is going to be a point, right? Looking down the Z-axis, if you would. And I'll give you time to catch up. You don't have to be doing this exactly with me. This is my x-axis in the top view. And then my Z is actually, my positive Z is going to come forward. And then the point here is the y-axis. And then on my right side view, the center, I'm not gonna identify it only because I know I'm gonna have to kind of go over the top of it. I'm looking down my x-axis, so I'm looking down the axis this way. And then that means that my vertical axis here is going to be my y. And then this axis right here is going to be positive Z to the left. So I'll give you a little bit of time to kind of get this in place, okay? Now, as we look at the elements that we have here, we know at A, we're going to have a V-belt shiv. B is going to be a bearing reaction. We're not going to do any calculating of that here. So we're just going to put an X through here, not because we're ignoring it, but it's to represent that that's a bearing. And it's a bearing here. And when we do our MD solids, we'll see those reactions come in, right? So there's nothing to put on there on this diagram here. We're only going to worry about the forces that are generated and transmitted to the center line of the shaft based on the machine elements that we have. Same thing at D. D is a bearing as well, so we can kind of X that out. And then we're going to focus on C, which is our chain sprocket, and then E, which then is going to be our gear. Okay. All right. So now let's start with our gear. Let's get that one out of the way. It's kind of like, I've heard the expression lately. I don't know if it's something that's new. I just lately I've been hearing like, eat the frog, get the one over with. That's, I think, the hardest because we have to kind of determine some things about the gear in order to get the directions in the right orientation. So when we look back at our problem statement for 12.2, it tells us that E delivers 80 horsepower to an electric generator. So what that tells me is that E, that gear, is a driver because it's sending from what it's getting from C out, right? It's sending. So whatever it's doing, it's driving. It's the driver for that pair, okay? And we have to look then as well here at the orientation of where it's at. Okay. Now they have this view looking down the shaft this way, but they also have on the next page, on page 527, this nice view where we can look down. Okay. So we are at point E here. All right. So the point of engagement is on the back side, if you would. So these orientations right now are looking down the x-axis. Okay. So this is A, B, C, D, and E down the x-axis. All right. So our right side view is right over here. So this is a right side view looking straight down at just the gear and what it's going to be driving. Okay. So this point of engagement. So right here's the shaft looking down that x-axis. Same orientation is our right side view right here. All right. Looking down the x-axis. So as we look here, since the orientation is back here, right? So that's where that engagement is. It's on the right-hand side here. The point of engagement is going to be where we start our radial force. Our radial force is always going to point from that point of engagement to the center of rotation. So you'll notice our radial force right here, is pointing from that point of engagement towards the center of rotation. So WRE, radial force, is going to be pointing to the left on the shaft. So what I'm going to do for this one, this is a little bit different. I've got 3 elements to try to get in here, and rather than trying to squeeze it around, what I'm going to do is I'm going to draw my WRE going to the left. Okay. We'll worry about orientations when we translate it up here. Let's put the tangential in place right away. Now the tangential, you'll notice they're giving us a direction of rotation for our shaft, and it's going in a clockwise direction. So when we go to that point of engagement, when we're a driver, remember we have to overcome the inertia of the gear that we're driving. So the tangential force goes in the opposite direction of rotation. So since this is going clockwise, then our tangential force from that point is going to go opposite that. So the arrowhead, when you look in your book, is pointing up. So we're going to show it like that here as well.
I remember talking about it, but I think getting the driven.
If we go back to page 513. Okay, 513. Here they have an example of the shaft and whether you're a driven or a driver. If you're a driven, your tangential goes in the direction of rotation. This one's pointing to the left. If you're a driver, like what we have here, now the direction of that rotation is still going in a counterclockwise direction, but the tangential force is going to be opposite that. So driver, the tangential is opposite. Radial is always the same. It always comes from the point of engagement and it's going to go back towards the center of rotation, no matter if I'm a driver or a driven. Okay. But you can always reference back here too, if you're wondering. Okay. You just have to know for a gear, am I a driver or a driven? So that one's going to go up and it's going to go in the opposite direction of rotation, perpendicular to. Okay. So now what we want to do is we want to pull these into our front and our top views. Okay. So now as we kind of take this and we're going to now orient it for a front view, you're going to notice that my WT, I'm going to see. All right. So I'm going to grab my here. My WT in my front view is going to be pointing up. And here is where I'm going to add WTE. I'm going to add its magnitude. Its magnitude comes from our spreadsheet. And it is going to be the tangential force, 494.12 pounds. Now, when you submit your free body diagrams, I'm expecting them to look very close to what I have here. Readable, straight lines, arrowheads on vectors. You guys didn't have me for statics. I'm a stickler for arrowheads on vectors. We are not drawing lines. These are forces, okay? They have to have arrowheads. All right. Now, as I'm looking here, when I push this and I am in my front view, now when I look straight down on it, my radial is going to go which way? Is it going to show up or down in the top view? Which way? Nope. You got to look down on it. You got to look down. Here's your top view, right? So you've got to look down on it. It's going to be going down. This is my WRE. And that magnitude comes from the radial, 179.84 pounds. Okay. Questions so far? So we've got our orientation of our gear forces. Now we're going to go to the orientation of C, just working left to or right to left. We'll go to our chain sprocket. So we know that our chain sprocket from the spreadsheet, we calculated the total force here of 815, but because it's at that angle, we need to use the components in the X and the Y direction. Now, this is going to be looking down that same orientation down the X-axis as a right view. So when I go here, you're going to notice that at C here, they're depicting C as a point. It's looking down the X-axis. So C is right here along that length of that shaft. And they're showing those forces, the Y going down and the X going to the left. Okay, this is your right side view looking down the X-axis. Make sense? So those are the two forces that we have. So what I'm going to do is I am going to take this off of here, and that's why I'm using pencil, because I've got 3 sets to do. And I'm simply going to redo it based on my new one. So if I go over here, my X is going in a negative direction. So as it says on the right-hand side in the comments, positive is equal to the right. So since this is negative, this is going to be 524 going to the left. So this is going to be my FC X. So it's the chain force X component. And then my FCY, it says it's negative. That one's going to go down. That one's going to go down. So that one's going to be an FCY going down, and that one's going to be 624.48. So now over here in my right side view, I have my FCX going to the left and my FCY going down. Yes.
So like on our homework, you want us to make separate ones?
You know, if you want to show the circles, I just thought it would be easier because we've got 3 of them. So you do have to show it though. Yeah, some way. If you wanted to do one here, and one here, that's fine. Just beyond 2, it gets like cluttered, at least for me. And I thought since I'm using pencil, I can just kind of show them. Yeah. All right. So now that we have those in the, I always think it's easiest to go on the right side view because that's where you see both of them. Now we want to pull them into our front and our top view. So I'm going to try to go like this. So we're on C now. So as we take this and we, put it up on its side and we look at the front view, my Y is going to go down because I see it right here. This is my Y in the front view. This is FCY. And that value is equal to 524. Do not put the negative in front of this. Why don't you want to put the negative in front of this? The vector's telling you it's going down. It's negative, right? And just like we did before, when we did the gear forces and we needed to figure out what is the magnitude, you're going to multiply it by itself to underneath the radical to get the resultant in the X and the Y. So you end up multiplying 2 negatives times themselves. Yes.
Isn't the FCY 624?
Oh, did I look at it wrong?
Yeah.
Oh, the Y, I'm so far. Sorry. Thank you, BJ. Thank you. Yes, it's 624. Yes, it's 624. Sorry about that. Thank you. Yes, the Y is 624. Make sure you get that right. And now the X. The X is pointing to the left in the right-hand view. So top view, which way is it going? Up or down? Did I hear it?
Down.
Down. Yep, it's going down. That's going to be our 524. FCX. Yep. Now, you'll notice we call this X and Y's, and this doesn't go in the X direction technically for our orientation. X's and Y's on our spreadsheet just refer to the fact that they're 90 degrees apart. That's it. That's it. Okay. So I'm going to keep that consistent with what's on our spreadsheet so we know where the number comes from. All right. Now we've got the V-belt shev. Okay. So the V-belt shev, you're going to notice is A. You see it over here. And as we look down the x-axis, we're going to notice that this is going to be the point view of point A. So now this time, because our shev is engaged up and to the left, okay, at the angle it is, our X and Y components are going to be shown in this orientation. So you're going to go back over here. And we saw that on our map, if you would, as well. So I'm going to erase that. Go back on our spreadsheet and look at our shev forces. Our shev forces are these two right here. Our X is going to go to the left. All went to the left. So this is going to be our S or our F. The X again. Oh, I don't like that. And then our Y is going to be up for this one. I'm on my shev, right? Yeah. F, C, Y. We'll just keep it consistent with what's there. And before I go back, well, I'll show you this one. So your FCY for this one, for our shev, is going to go up in the Y, to the left in the X, as we see. Now go ahead and put your values into the front and the top view. show these two forces in the front and top view. So in the front view, is my arrowhead pointing up or down? At A. Front view. So this one here, this is consistent. This is always going to be when I look at the front view, it's going to be in that same orientation. So in the front view, this is still going to go up. And this is going to be FCY. And that number was, what was it? 481.5. And then our FCX. Jacob, which way is this one going? The X one in the top view. That one's going down. Yep, they all went down. So that's going to be here. And that one, this was the Y value, or I'm sorry, the X value, right? Yeah, the X. That one's 278. 278. Okay. Any questions? Translating what we see there. This is usually the challenge, okay? Making sure that you have your forces going in the correct directions based on the elements and being able to visualize like which way they go. I find the easiest is to start on the right side view and then bring it into the front and the top views, okay? So you're exercising those orthographic projection muscles, right? I've done that for a while, maybe. Okay. All right, next step is going to be MD solids. I'm going to stop this recording here again. We'll do a separate one for MD solids. Make sure that we can do that again, kind of segmenting it out a little bit so that when you need to go back to certain parts, it's not like trying to sift through an hour and a half lecture. Okay, so I'm just going to stop here for a moment.